We are starting, three systems simultaneously. Our HOD sir will be dealing with the general physiology, and Dr. Subhashish will be dealing with the hematology and blood and all these things. And I will be entering directly into the cardiology, right? Okay, the cardiovascular system. Okay, and the most difficult topic in cardiovascular system for you, mostly what I have experienced, students face difficulty in understanding and interpreting ECG, right? So I can't teach you directly, I can't enter directly into ECG or electrocardiograph, right? Electrocardiogram. So before that, we need some preliminary knowledge. Okay, yes, I will be starting with ECG, but to start with ECG, it is very difficult for cardiovascular system to directly enter into ECG, right? So before that, we need some prerequisite knowledge, right? And most of the things will be covered under general physiology, particularly the electrophysiology. Okay, so to understand the electrical activity of heart, you need to be well versed with the electrophysiological properties of cells. Okay, to start with, you need to know the cells which are excitable. Okay, the cells which are excitable, and you need to know what is membrane potential, right? What is membrane potential? So I will start with the term resting membrane potential. Okay, I am entering into electrophysiological property of a cell. Okay, and that cell might be any cell. That cell might be a cardiac muscle, that cell might be a smooth muscle, that cell might be a skeletal muscle or a neuron, right? Okay, so I am coining one term. Okay, I am starting with one term, that is resting membrane potential, right? Resting membrane potential. Okay, so what is resting membrane potential? Let me define resting membrane potential for you, right? Every animal cell, remember every animal cell, I am not telling all cells, every animal cell, so not plant cells. Okay, so every animal cells maintains a potential difference across the cell membrane where the inside of the cell is negative in respect to the exterior, right? So if you take a cell, right, if you take a cell, inside is negative and outside is positive, right? So if you take a cell and take the cell membrane, if you insert microelectrode into the cell, one microelectrode inside the cell, another microelectrode outside the cell, and you measure a potential difference, you will get a potential difference, right? So the definition of resting membrane potential is every animal cell maintains a potential difference across the cell membrane where the inside of the cell is negative in respect to the exterior. This potential difference is called resting membrane potential. Okay, this potential difference across the cell membrane is called resting membrane potential. Okay, so you have a cell, inside is negative, outside is positive. You put one microelectrode inside the cell, one microelectrode outside the cell. You connect the two wires with a voltmeter inside, voltmeter at the middle, right? And you get a potential difference, you get a deflection, right? So one microelectrode inside, one microelectrode outside, and you connect this with a voltmeter and you get a potential difference, right? And this potential difference is called resting membrane potential, and each animal cells maintain a resting membrane potential wherever the cell is located. It might be any cell, okay, an epithelial cell, a skin cell on the skin, right? A hepatocyte, right? A nerve cell, a muscle, right? Every animal cell has got this resting membrane potential. Now next question is, what is an excitable cell? Okay, what is an excitable cell? So to know what is excitable cell, you need to know what is polarized and what is depolarized. Okay, so when the cell is in resting membrane potential or the inside of the cell is negative in respect to the exterior, we call it the cell is polarized. Okay, we call it the cell is polarized. Okay, And there are many cells in human body which are excitable. That means the cells are excitable. That means you can change the polarity of the cell, okay, by applying external current. You can change the polarity of the cell by applying external current, or there might be some causes which open some channels, okay. Yes, you don't know what is a channels, okay, what is a channel, okay. So there are lots of membrane protein. From your 10+2 knowledge, from your higher secondary knowledge, you know that cell membrane is a fluid mosaic model, right? Cell membrane is a fluid mosaic model, and it is a protein lipid structure, right? And there are multiple proteins embedded within this cell membrane. Some are integral protein and some are peripheral proteins, and these proteins may be enzymes, these proteins may be carrier, this protein may be ion channels, right? Okay, so in animal cells there are some proteins called ion channels because they transport ions, like sodium, like potassium, like calcium. They transport ions. Like chloride, they transport ion maybe from inside to outside or outside to inside. So cell membrane has got channels, okay. Cell membrane has got channels, okay. So through these channels, ions can either enter or exit, okay. So there are lots of things on channels, what are their classification, and depending on their voltage property, we classify channels. So all these things will be taught under general physiology, the classification of ion channels, okay. So depending on which ion the channel is transporting, depending on that, we can name like sodium channel, potassium channel, chloride channel, right? In this way, calcium channel, okay. So there are lots of channels at the cell membrane, and different cell has different properties. Not cardiac muscle cell has got calcium channel, skeletal muscle has got calcium channel, okay. Some cells have got different types of channel, okay. So there are these types of channels, right? Now with the help of these channels, by applying external current or external stimulation, that external stimulation may be electricity, that external stimulation may be thermal stimulation, that external stimulation might be a chemical, or simply some mechanical stimulation like stretch, right? Okay, so by applying some external stimulation, you can initiate, okay, you can initiate, or some chemical stimulation, you can open or close those channels, okay, by applying some stimulation, maybe chemical, maybe electrical, maybe mechanical, right, maybe thermal. By applying those stimulations, you can open or close those channels, and by opening or closing these channels, you can change the polarity of the cell, okay. You can change the polarity of the cell. So say for example, this line is resting membrane potential, the baseline resting membrane potential, the cell is at resting membrane potential, okay. Say for example, this resting membrane potential is minus 90 millivolt, okay, minus 90 millivolt. We measure membrane potential in millivolt. The electricity, the wiring which we are using in our day-to-day life, we measure in volt, in ampere, right? The resistance in ohm, right? But in electrophysiology, potential difference we will measure in millivolt, okay. And the flow, electric current flow, we will measure in milliampere, correct? Okay, so say for example, for this cell, the resting membrane potential is minus 90 millivolt, okay. Now what will happen if a positive ion, say for example sodium, enters into the cell? If sodium enters into the cell, inside will become positive, right? Inside will become positive, right? So the cell, say for example sodium is entering through sodium channel, through a voltage gated sodium channel. Now the situation is, this is minus and this is plus, because the inside is filled with sodium, right? Okay, now the polarity has changed, and we call the cell is depolarized, okay. We call the cell is depolarized, okay. So the membrane potential rises, and may reach up to, say for example, plus 30 millivolt. It was minus 90 millivolt, which we are calling resting membrane potential, right? Now, as sodium enters inside the cell, membrane potential is increasing. This x-axis is membrane potential, okay, and this y-axis is membrane potential and x-axis is time. Correct? Y-axis is membrane potential and x-axis is time. And at the beginning, membrane potential was minus 90 millivolt, which we are calling the resting membrane potential. Now, as sodium enters into the cell, inside is becoming positive in respect to the exterior. So, inside is positive in respect to the exterior. So, just the polarity has been changed, right? And we are calling this cell is depolarized. Okay? So, now the cell is depolarized. Okay? Now, after this event, say for example, after this depolarization, the cell will not remain depolarized. It has to be polarized again, right? So, sodium has enters into the cell is now polarized. Now, the cell will try to be polarized again, come back to resting membrane potential, because when the cell is depolarized, it is not stable. The cell is not stable, okay? Electrochemically, the cell is not stable. The cell will try to come back to resting membrane potential, okay? So, say for example, now potassium channels opens. Potassium channels open. Now, potassium will exit from the cell, right? Potassium ion will exit from the cell through a voltage gated potassium channel, right? Through a voltage gated potassium channel. So, now it will try to come back to resting membrane potential once again and come back to the stability. But during the process, potassium exists and membrane potential sometimes comes below the resting membrane potential, right? Below the resting membrane potential. That means inside become more negative, okay, even more negative than resting membrane potential, okay. So, we call it hyperpolarization. Hyperpolarization. Correct? Hyperpolarization. We call this hyperpolarization. Okay. Now, after hyperpolarization, it will come back again to normal resting membrane potential. Clear? Okay. So, normally, when we call the cell is polarized, inside is negative, outside is positive, we call it resting membrane potential. Let me define resting membrane potential again. Every animal cells maintains a potential difference across the cell membrane where the inside is negative in respect to the exterior, and this potential difference is called resting membrane potential. Okay. Now, when the polarity is changed and inside become positive and outside negative, we call it cell is depolarized. Okay. And when inside becomes more negative, we call it hyperpolarization. And from depolarization to this is called repolarization. Repolarization, coming back to resting membrane potential, is called repolarization. So, what you need to know, questions for you: what is resting membrane potential, what is depolarization, what is repolarization, and what is hyperpolarization. Okay. Okay. Now, the thing is, every animal cell maintains potential difference across the cell membrane, and every animal cell has got a resting membrane potential. But all the animal cells are not excitable. That means you cannot change membrane potential for all cells. There are specific cells in our body which are excitable and others are non-excitable cells. Okay. Getting my point? So, all cells are not excitable. You cannot change the membrane potential. Okay. Why you cannot change the membrane potential? Very nice. There are absence of ion channels, because ions are responsible for changing membrane potential. Sodium will enter, potassium will exit. So, the cell membrane must have the voltage gated sodium channel, voltage gated potassium channel, voltage gated calcium channel, or whatever, any other type of channel which will transport ions across the cell membrane, right? So, to be excitable, to be excitable, that means to be excitable means resting membrane potential to depolarization, to be depolarized. So depolarization होने के लिए the cell must have the ion channels, okay, must have ion channels, right? Ion channels থাকলে তবে সেলটা depolarize হবে, clear? Okay, so all cells are not excitable. Examples of excitable cells are, yes, neuron, muscle cell, neuron and muscle, most important, neurons and muscles, okay, neuron and muscles are excitable cells, and under muscles you have the smooth muscle, you have skeletal muscle, and you have cardiac muscles. These are excitable cells, right? Because they have plenty of ion channels which can change the polarization of the cell, which can take the cell to depolarization, which can take the cell to hyperpolarization depending on the situation, right? Okay, clear? Now next, you know what is resting membrane potential, you know what is polarization, what is depolarization, what is hyperpolarization, right? And you know what are excitable cells, and why some cells are called excitable cells and not the other cells, right? Why some cells are excitable? You all know these questions, answers of this question, right? Okay, okay. Now next, what you need to know, two things. One is action potential. Okay, again introducing one term, action potential. You know what is resting membrane potential, but what is action potential? Let me give you an example, okay? Let me give you an example. What is action potential? Yes? It will again come back to resting membrane potential. Okay. So, resting membrane potential to depolarization, depolarization, say repolarization, and over repolarization, hyperpolarization, right? Hyperpolarization, and come back to resting membrane potential, right? Okay. Now, let me give you an example. A cell, right? An excitable cell, definitely an excitable cell. I'll do an experiment. Assume we are doing an experiment with an excitable cell. We have an excitable cell, and we will apply electricity to that cell membrane, so that the cell is excited and the cell membrane potential moves towards depolarization. Okay? So nice, you have a cell and you are applying electricity on the cell membrane, okay, not big enough, okay. So you are applying electricity to the cell membrane so that the cell is excited. What will happen? The cell has a resting membrane potential, right? The cell has a resting membrane potential. You apply a stimulus. Whenever you are applying a stimulus, it should be measurable, right? It should be measurable, and we, for all experiment purpose, we use, or scientists use electricity as a stimulus, because it can be very well measured. Okay, I told you that stimulus may be chemical stimulus, may be thermal stimulus. Okay, we can apply heat, thermal stimulus, we can apply cold, right? We can apply some chemical, we can apply some stretch, but these are difficult to measure, right? But if we apply some electricity, you can measure. ठीक है? कितना टाइम से आपको देना है इलेक्ट्रिसिटी, कितना ड्यूरेशन से, क्या मैग्नीट्यूड देना है, तो वी कॉल इट स्क्वायर्ड पल्स स्टिमुलस. Okay, so say for example, this is the stimulus you are applying for a particular duration and for a particular magnitude. Okay, इलेक्ट्रिसिटी मुझे देना है for a टाइम पीरियड एंड इसका भी मैग्नीट्यूड है, कितना जूल एनर्जी देना है, कितना ड्यूरेशन से देना है, कितना एम्पियर देना है, ठीक है. सो एवरीथिंग वी कैन मेजर, राइट. सो आई एम अप्लाइंग दिस मच ऑफ इलेक्ट्रिसिटी एंड रिजल्ट व्हाट आई एम गेटिंग in experimental setup we have already applied microelectrode, right? Inside, outside. We have applied microelectrode and there is a voltmeter as well that will measure the potential difference across the cell membrane for me, right? Okay. So, I have applied this much of stimulus and what I am getting, this much of membrane potential fluctuation. Okay. So, from resting membrane potential it will rise, depolarize and come back, right? So, now what will I do? I will increase the magnitude of my stimulus. Electricity increase karna hai, right? So, this much stimulus, this much change in membrane potential. This much stimulus, this much change in membrane potential, right? So, as I am increasing the magnitude of my stimulus, electricity मैं बढ़ा रहा हूँ, right? And I am getting increased depolarization. ठीक है? जितना ज़्यादा आप stimulus दोगे, उतना ज़्यादा depolarization होगा. The more I am applying stimulus, the more is the change in membrane potential. Change in membrane potential. What I measure? The del Vm, change in membrane potential, right? Resting membrane potential यहाँ पर था. So this is the change in membrane potential, right? So what I need to measure is the change in membrane potential. The more electricity I am applying, the more is the del Vm, change in resting membrane potential. Getting my point? So it is proportional. But by doing this thing, a time will come when you are applying this much of stimulus and you will be getting this. So this is quite absurd, right? Okay. So initially at the beginning, मैं जितना electricity दे रहा था उतना membrane fluctuation मिल रहा था मुझे, right? And I'm increasing the membrane stimulus, increasing the stimulus, increasing the del Vm. But a point will come when I will apply some amount of stimulus, definitely greater than before, but the result is huge, not in proportion to the stimulus applied. Getting my point? Now, ये जो stimulus है, right? मैं इससे भी ज़्यादा अगर stimulus देता हूँ, say for example this, my response will be same, this. Okay. So after this, इसके बाद अगर आपका stimulation बढ़ाते हो, फिर भी the height of membrane potential is not increasing. ये maximum limit है, right? So at the beginning, the response or the change in membrane potential was proportional to the stimulus applied. But up to a certain point, a point will come when the change in membrane potential will be maximum even after increasing the strength of stimulus, del Vm is not increasing. It remains the same. Okay, and this is the maximum change in membrane potential. इसके बाद आप और membrane potential को change नहीं कर सकते. ठीक है? This is the maximum limit. Okay? Now, this maximum change in membrane potential, this is called action potential. Okay? So इससे पहले क्या हो रहा था? Action potential से पहले क्या हो रहा था? The छोटे-छोटे fluctuations, all the small fluctuations in membrane potential due to small amount of electricity, due to small amount of stimulus application, all these are called electrotonic potential, EP. Okay, all these are called electrotonic potential, EP. Okay, EP has no fixed height. If you increase your stimulus, EP will rise. Okay, but once there is action potential, you cannot change the height of action potential. Okay, so action potential is all or none. Either ये होगा और नहीं होगा, right? So action potential is all or none. इसके बाद once action potential has happened, इसके बाद even if you are changing your stimulus, the height of action potential will not change. It will remain same for that cell. Okay, for that cell action potential will remain same. So you have, now you know what is electrotonic potential and one is action potential. Now you need to define action potential. What is action potential? And you need to know its explanation, why action potential is happening. Okay, why action potential is was not happening before. ठीक है, इससे पहले action potential क्यों नहीं हो रहा था? और once action potential has happened, इसके बाद even if I am increasing the stimulus, the height of action potential is not increasing, it is fixed. Okay, so you need to answer all those questions. So first let us define what is action potential. So write it down. Action potential, it is the rapid and active change in membrane potential. Rapid and active change in membrane potential due to application of threshold stimuli. Due to application of threshold stimuli followed by return to RMP, resting membrane potential. Right? Let me repeat. So what we are doing? We are defining action potential. It is a rapid and active change in membrane potential due to application of threshold stimuli. Threshold stimuli. Okay. So rapid and active change in membrane potential due to application of threshold stimuli followed by return to resting membrane potential. Okay. Action potential is defined as rapid and active change in membrane potential due to application of a threshold stimuli followed by return to resting membrane potential. Clear? Okay. Now what is threshold stimuli? Anyone? What is threshold stimuli? Yes, the minimum amount of stimulus required to generate action potential. The minimum amount of stimulus required to generate an action potential. So you can understand from this, right? So you apply stimulus, no action potential, it is electrotonic potential, it is EP, right? It is EP or electrotonic potential. Electrotonic potential. Okay, so you apply a stimulus, you get electrotonic potential. You are increasing the amount of stimulus, you are getting a greater EP, right? Again you are increasing the amount of stimulus, again you are getting an EP. Right? But the height of EP is increasing gradually. Now you are applying this much of stimulus and you are getting action potential. Right? And iske baad again another stimulus greater than before, same, you are getting same action potential. So once action potential is generated, it is always same in magnitude, in height and in duration. It is always same. Right? So electrotonic potential is incremental, but action potential, it has got a fixed height. So action potential is rapid and active change in membrane potential followed by return to resting membrane potential, and electrotonic potential is just replace the word active with passive. Okay, electrotonic potential is passive change in membrane potential due to application of subthreshold stimuli, not threshold, because once you apply threshold stimuli, there will be action potential. If you apply subthreshold stimuli, there will be electrotonic potential. Clear? Okay. So definition of action potential is rapid and active change in membrane potential due to application of threshold stimuli or suprathreshold stimuli followed by return to resting membrane potential. And what is electrotonic potential? It is a passive change in membrane potential due to application of subthreshold stimuli. Okay, followed by return to resting membrane potential. ठीक है? Okay. So now the ionic basis behind it. Why sometimes electrotonic potential and why sometimes action potential? Okay. The answer is simple. Okay. The answer is simple, but let me give you an example. Okay. So you have a plate, a dish, right? A dining dish. So you have a dish this side and you have 2 rasgullas on it. ओके आपके पास एक प्लेट है एंड उसके ऊपर 2 रसगुल्लास रखे हैं, ठीक है। इधर भी एक प्लेट है, आपके पास भी एक प्लेट है एंड इसमें भी देयर आर 2 रसगुल्लास। ओके, नाउ आई विल पुट 2 rasgullas on this plate. So now this plate has got 4 rasgullas. Okay, and here I didn't place any more rasgullas on it, but suddenly you see there are 6 rasgullas. Clear? Nobody kept rasgullas on it. It was 2, but now it is 6. Okay, so extra 4 rasgullas kahan se aaya? Answer is the plate has generated some rasgullas. The plate has the capability to generate some rasgullas. Okay, now your plate is your cell membrane and the rasgullas are each coulomb of electricity. ठीक है? Okay, so यहाँ पर मैंने चार्ज दिया था. I have given stimulus. Okay, I have given stimulus. Right? This is why now the plate is having 4 coulomb. One rasgulla is 1 coulomb. Okay, 1 rasgulla is 1 coulomb. Okay, so here I have applied extra electricity. So initially it was 2, now it is 4 because I have kept 2 more, right? Now here in this plate I had kept only 2, not more than that. But suddenly you find there are 6 rasgullas, matlab 4 extra coulomb of charges. So extra electricity has been generated by the plate, and the plate is cell membrane. Okay, the plate is cell membrane. Correct? The plate is called cell membrane. So how does it work? You apply electricity to the cell membrane, microelectricity. You apply electricity to the cell membrane, right? And as a result, what happens? There are opening of some voltage gated sodium channels, right? So here is the cell membrane. Here is the cell membrane. You apply electricity. Right? As a result of this external stimuli or external electricity, the cell has opened its voltage gated sodium channels. Okay. The cell membrane has got numerous sodium channel, voltage gated sodium channel, which can sense what? Voltage. Okay, voltage gated sodium channels. That means a sodium channel that will open when electrically stimulated. So voltage gated sodium channel. Gate is operating, gate will open or close depending on the membrane voltage. By applying external electricity, you are changing the membrane voltage, right? You are changing the membrane voltage. As a result, the sodium channel will open. The sodium channel was closed, now it will open. Okay? And you know, in our extracellular fluid, cell के बाहर में जो fluid है, right? वहाँ पर sodium ज़्यादा है, potassium कम, right? So what will happen when the sodium channel opens? Sodium will enter into the cell and it will cause depolarization. Now there is a term called the critical number of sodium channel. The critical number of sodium channel. Say for example, हमारा जो cell है इसमें 1 lakh voltage gated sodium channels है, right? For example, it might not be the actual situation, right? So assume this cell has got 1 lakh sodium channel and you are applying some electricity to it. So out of this 1 lakh sodium channel, say for example 100 channels will open. Okay, so 100 channels will open and through these 100 sodium channels, sodium will enter into the cell and it will cause a firing. change in membrane potential. This change in membrane potential, this depolarization, we call it firing. The cell will fire. Okay. So you apply stimulus, 100 sodium channel will open, right? You increase the amount of stimulus, say 1000 sodium channel will open. Okay. You again increase the stimulus, say for example 50,000 sodium channels are open, right? You again increase the stimulus, 99,999 sodium channels are open. Just one come from 1 lakh. Okay. Okay. Now slightly you are increasing the strength of the stimulus, 1 lakh sodium channels are open. Okay, and you get action potential. Clear? Before that you were getting small electrotonic potential. Now when 1 lakh sodium channels are open, you get this action potential. So 1 lakh is the critical number for that cell. Okay. To generate action potential, you need to apply sufficient electricity so that all the critical number of sodium channels are opened simultaneously. Okay. So to generate an action potential, you need to apply sufficient stimulus to the cell so that all 1 lakh sodium voltage gated sodium channels are opened simultaneously. Okay. Then you get action potential. If the number of sodium channels that are opening are below 1 lakh, 1 lakh से कम sodium channel अगर open होता है, so you cannot get action potential. Okay. Okay. So again, you can define threshold stimulus in a different way. Threshold stimulus is the minimum stimulus which can open critical number of sodium channels, right, simultaneously. Okay. Critical number of sodium channels should open एक साथ simultaneously. Clear? Okay. So this is the funda that yes. ठीक है. आप say for example you are applying 10 unit electricity, so you are getting 10 voltage gated sodium channels opened, right? You are applying 20 unit of electricity, you are applying 20 unit of electricity, so you get 10, you get 20. You are applying 30, you are getting 30. But now when you are applying, say for example 50 or 100, okay, you get huge. Okay, this extra electricity has been generated by the cell membrane. Cell membrane is generating extra electricity means the cell membrane is deploying all the channels simultaneously. That is not proportional to the stimulus you have applied. आपने जितना दिया था उतना नहीं है, उससे भी ज़्यादा आ रहा है. That is extra rasgullas the membrane has produced.
So they have different potential compared to them.
Definitely. Height देखो, height is more in case of action potential.
Sir, if you give the same action to both of the cell membrane, so sir, one is producing 2, another is producing 4. So why is that so? Like, do they have different potential?
No.
Or do they compare with itself?
You will get it when you will study the property of a voltage gated sodium channel. Okay. All the voltage gated sodium channels has got a particular voltage they are most sensitive with, right? All the voltage gated sodium channels has got a particular voltage they are sensitive with. When that particular voltage is given to that cell, all the voltage gated sodium channels will open simultaneously. But before that optimum voltage was not getting. Okay, the cell was not getting the optimum voltage, so that critical number of sodium channels will open. Now whenever you are applying the optimum voltage, the voltage gated sodium channels are most sensitive with, right? They will open simultaneously. Okay, clear? And you can again define action potential in a very different way. Action potential is the rapid and active change in membrane potential due to opening of critical number of sodium channels simultaneously. Okay, my previous definition of action potential was it is a rapid and active change in membrane potential due to application of threshold stimuli followed by return to resting membrane potential. Now I am defining action potential in a very different way, right? Action potential is defined as the rapid and active change in membrane potential due to opening of critical number of sodium channels simultaneously followed by return to resting membrane potential. Getting my point? So you can define action potential in both ways. Okay? Okay, chalo. Now, when action potential is generated in a cell, right, the cell can transmit. Okay, when action potential is generated at a particular cell, the cell can transmit this action potential from one cell to another. The cell is attached to it, right? Okay, so assume, so here is a wall, right? Here is a wall, and this wall is made up of bricks. So you assume all the bricks as a cell. Okay, so when there is action potential, so it is not only for action potential, even electrotronic potential can also be transmitted from one cell to another. But the difference is, very often in your Viva examination, your examiner will ask you what is the difference between action potential and electrotronic potential. Okay, so tell me the differences. Let me see your knowledge by now. Yes, definitely. Action potential is active and electrotronic potential is passive. Okay, and action potential is all or none. इसका height fix है, right? And electrotronic potential is incremental. आप जितना stimulus दोगे उतना आप height पाओगे, right? Yes, yes, yes. Action potential is generated due to application of threshold stimuli or supra-threshold stimuli, and electrotronic potential is generated due to sub-threshold stimuli, right? Action potential generate करने के लिए you need to open a critical number of sodium channels simultaneously. Critical number of voltage gated sodium channels simultaneously, right? Okay, for generating electrotronic potential, no need of opening critical number of sodium channels simultaneously. Okay, below critical number. Clear? So there are numerous differences, and another major differences what I am trying to tell you now is the travel. Okay, so electrotronic potential can travel one cell to another. Okay, electrotronic potential, yes, it can travel from one cell to another. Let me delete it. So assume you have cells in a series. You have all the cells in a series. Right? So all the cells in a series. So say for example, this cell 1, 2, 3, 4, 5, 6, cell N. Right? So cell 1, 2, 3. Say for example, ये वाला जो first cell है, so there is generation of electrotonic potential, EP. EP. What will happen? The cell will transmit this EP to the next cell, right? So next cell, next cell, next cell, next cell, next cell. So क्या हो रहा है? So the electrotronic potential is decreasing its strength. इसका power loss हो रहा है धीरे धीरे as it is traveling from one cell to another. The strength of electrotronic potential is decreasing. Okay, and lastly आप यहाँ पर आओगे and you measure the voltage. There will be no fluctuation at all. Okay, there will be no change in membrane potential. Okay, so electrotronic potential एक number cell में generate हुआ था, right? Now it will travel and it is losing its strength. Okay, जैसे say cyclone type of thing. एक जगह जनरेट होता है, राइट, एंड ग्रेजुअली एयर का स्पीड कम होते जाता है, यस यस, डिक्रीज होच्छे, राइट, आई विल कंप्लीट. So the strength of electrotonic potential is gradually decreasing. Okay. In contrast to that, what is happening in action potential? It is not decremental. Action potential 1, action potential 2, action potential 3, dot 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 dot. Even here, action potential n with same height. ठीक है, एक्शन पोटेंशियल यहाँ पर भी इतना, यहाँ पर भी इतना, यहाँ पर भी इतना, यहाँ पर भी इतना, एन पे भी इतना, ठीक है. एंड व्हाट वाज देयर इन इलेक्ट्रोटॉनिक पोटेंशियल? यहाँ पर इतना, यहाँ पर इतना, ठीक है. सो इलेक्ट्रोटॉनिक पोटेंशियल इज लूजिंग इट्स स्ट्रेंथ एक्सपोनेंशियली, ठीक है, एक्सपोनेंशियली इट इज लूजिंग इट्स स्ट्रेंथ. But action potential is all or none, ठीक है. Action potential is all or none. It will travel unlimited distance, ठीक है. It will travel unlimited distance. Now, if I give you example, yes, I'll come to it. Okay. The farthest length action potential has to travel. Okay, the longest length or the farthest length action potential has to travel is your height, ठीक है. That means action potential आप सेल जोड़ जोड़ के कितना भी दूर ले जाओ, ठीक है, यहाँ एक सिटी से दूसरा सिटी चला जाओ तो भी action potential travel होगा theoretically, ठीक है. But in a human body, say for example a neuron can sense various stimuli like pain sensation, like heat sensation, touch sensation, right? So say for example there is a pin prick in my foot and that pain sensation has to travel my height and my somatosensory area in my brain and I will sense pain. Okay. So action potential has to travel my height, right? So action potential must be generated there. Action potential must be generated there. If it is not action potential, it is electrotonic potential, say for example. So it will travel, say for example, somewhat up to here, up to here, up to here, then it will fade out, right? So to get the sensation, it has to travel to the highest distance. What is there? There are basically neuronal connection. There is a first degree neuron, there is a second degree, that neuron, that sensory neuron, it will travel, enter into my spinal cord, and through this spinal cord, it will travel to my somatosensory area, where I will sense pain, right, due to pin prick, right? So it has to be action potential to reach my somatosensory area, okay? If it is electrotonic potential, it cannot travel up to my brain, right, the sensory area in my brain. It has to be action potential, okay? And say for example, someone, taller than myself, so it must be action potential. It has to travel up to his head, clear? Okay, so action potential, it will travel without losing its strength, without losing its magnitude, right? So here is the major difference between electrotonic potential and action potential. Electrotonic potential fades out after traveling some distance exponentially, okay, and action potential travels from one cell to another, okay, it is called saltatory conduction, okay. Action potential travels from one cell to another without losing its strength, ठीक है. यहाँ पर जितना एक्शन पोटेंशियल मिलेगा ये वाला सेल में, यहाँ पर भी उतना ही एक्शन पोटेंशियल का स्ट्रेंथ मिलेगा, राइट? आप जितना भी दूर चले जाओ, यूएस चले जाओ, यूरोप चले जाओ, सेल जोड़ जोड़ के, theoretically it is possible. So same action potential in India, same action potential in Europe, clear? Okay, theoretically it is possible. If you connect cell and go to US, the same action potential height and magnitude you'll get, clear? Okay, I'll explain. Okay, there will be separate doubt clearing session as well. Okay, so This is action potential, clear, which is the basis of understanding ECG. So gradually we will come to ECG. So before that you need to know cell electrophysiology. Now I will enter into cardiac cell, cardiac muscle cell. How an action potential look like in a cardiac muscle cell, okay, and what are the ion channels involved in cardiac muscles, right? Okay, so cardiac action potential. The thing is, in heart there are cardiac muscles, right, and there are conduction tissues. There are conduction tissues, okay. So what are those conduction tissues? There are two different types of cells, basically two different types of cells. One is conduction tissues, which are usually modified myocytes, okay, modified cardiomyocytes, okay. So the conduction tissues are one type of cell and the normal myocardium is another type of cell. The difference is the number of gap junctions. Yes, I am introducing another new term to you, that is called gap junctions, okay. So what are gap junctions? Gap junctions you will study in your general physiology classes. Gap junction is a connecting bridge between two adjacent cells, okay. Gap junction is a specialized connection, okay. It is not just attachment, just physical attachment between two cells, okay. It is a specialized connection between two adjacent cell, okay. It is a specialized connection between two adjacent cells, and the number of gap junction determines how efficiently a cell can transmit its voltage to another cell, okay. So एक सेल में एक्शन पोटेंशियल हो गया, इसका मतलब this cell is now what? Depolarized, okay. So एक सेल में एक्शन पोटेंशियल जनरेट हुआ, that means the cell is now depolarized, okay. Now if this action potential travels from this cell to all the adjacent cells, okay, so this is the primary cell, यहाँ पर action potential हो गया. Now this cell has got gap junctions here, gap junctions here, gap junctions here, and gap junctions here, okay. So through this gap junction, the primary cell in the middle, it will transmit action potential to all the cells surrounding, ठीक है. So action potential यहाँ पर generate हुआ, इसका मतलब action potential will come here, come here, come here, come here, right. So all the cell will depolarize, okay, and this depolarization wave, it will travel from one cell to another, ठीक है. इसके साइड में 4 सेल है, इसके साइड में और 4 सेल है, इसके साइड में और 4 सेल है, ऐसे करके एक्शन पोटेंशियल विल ट्रैवल in a fashion like, you know, Wi-Fi signal, right. So action potential will travel, right, clear. So simply, so if you consider this as this hall as LV, left ventricle. So we are inside left ventricle, right? We are inside left ventricle. This this hall is left ventricle, okay. And there are bricks, okay. There are bricks, okay. Now if you depolarize one brick, it will depolarize all the bricks surrounding it, okay. Now if you are able to depolarize one small brick here, the whole ventricle will get depolarized. क्या होगा? If the whole ventricle is depolarized, কি হবে তারপরে? Yes, it will contract and it will pump blood, right? So this is the mechanism. Okay, this is the mechanism. You need to just depolarize one cell of heart, right? Of left ventricle. ठीक है, लेफ्ट वेंट्रिकल में जस्ट एक सेल को डिपोलराइज कर दो, राइट, एंड इट विल डिपोलराइज ऑल द सेल्स, ओके, इन अ फ्रैक्शन ऑफ सेकंड. So all the cell will depolarize. When the whole ventricle is depolarized, it will pump, it will eject blood into your systemic circulation, correct? Okay, this is the mechanism, and it will repolarize again, blood will come back here. Okay, so we are in the left ventricle. We are inside the left ventricle, one break is depolarized, all the breaks are depolarized, the wall will contract and all of us blood will be ejecting out. Clear? So this is how it works. Clear? Okay, gap junctions. So gap junction is a specialized connection between two adjacent cells, okay, and the number of gap junctions in a cell, it will determine how efficiently it will conduct action potential to the next cell. ठीक है? So say ये वाला एक सेल है, ये वाला एक सेल है, ये भी सेल, right? Now इस सेल में 10 गैप जंक्शन है and इस सेल में 100 गैप जंक्शंस है, right? So it will transmit action potential more efficiently than this, right? So it depends on number of gap junction, how efficiently you are transmitting electricity to the next cell. ठीक है, right? क्लास में एक बच्चा बदमाश है तो सारे बदमाश हो जाता है, ठीक है? ओके, सो एजुकेशन सर, ठीक. सो क्लास में एक बच्चा बदमाश है, सो ही विल ट्रांसमिट टू दिस बगल वाला, राइट? उसके बाद सारे नॉइज कर रहे हैं, ठीक है? सो दिस इज हाउ इट वर्क्स. द कार्डियक सेल, वंस one cardiac myocyte is depolarized, all are depolarized, okay? And the property of cardiac muscle is such that it has got huge number of gap junctions in its cell membrane, right? And also you need to know the structure of gap junction, which is a part of general physiology. I am not going into the details of structure of gap junction. It is basically made up of 6 proteins, and the proteins are called connection protein, okay, which is very frequently comes in your post graduation NEET MBBS entrance, right? The name of the protein, the answer is connection, okay? When there is mutation of this connection protein, there are lots of diseases, we will discuss later on, right? We call it connexinopathy, okay, connexinopathy. So there are connexin protein, one cell contributes 6 protein, another cell contributes 6 protein, and there is a tunnel, in between through which ions can pass. This is why action potential can travel from one cell to another. If action potential has to travel from one cell to another, there must be some way, and the way is gap junction, and gap junction is nothing but simply a tunnel which is made up of 6 protein by this cell, 6 protein by this cell, okay? Cell A, cell B, cell A contributes one cell A contributes 6 protein, cell B contributes 6 protein, okay, connexin protein, and there is a tunnel. Through this tunnel, ions can pass, voltage can pass, right? So that bagal wala cell is also depolarized. Clear? And the number of gap junction will determine how efficiently a cell can transmit action potential from one cell to another, right? And the good thing in cardiac muscle is that all the muscle cells are having numerous number of gap junctions. This is why quickly it is depolarized. If you depolarize only a single cell in heart, all the cardiac muscle cells are depolarized very quickly, right? And it contracts. When there is depolarization, contract. When there is repolarization, relax. Okay? This is the very basic mechanism of systole and diastole, right? Okay. Okay. Now this action potential is traveling from one cell to another, okay? When action potential is traveling from one cell to another, there is simply a flow of electricity which can be recorded, right? when action potential is traveling from one cell to another in your heart, say for example atria, ventricle. So action potential कहाँ से generate होता है in heart? SA node, yes, SA node. Okay, so SA node which is in atria, right? SA node. So from SA node action potential, मतलब atria to ventricle, action potential is traveling from your atria to ventricle. Okay, so simply there is a flow of electricity in this side, right? And you can record that electricity, you can capture that electricity by applying some external electrodes. ठीक है, just skin के ऊपर यहाँ पर आप electrode बैठा दो, right? And you can record that travel of electricity, that travel of action potential from external skin surface. This is called ECG. Clear?